You're about to see corporate headquarters that look like they were designed in the year 2125. While the rest of the world builds glass boxes, China's tech giants are constructing impossible loops, floating towers, and structures that twist toward the sky like DNA spirals. These aren't concept renders or fantasy projects, they're real buildings where hundreds of thousands of people work every single day. 12 headquarters that prove the future of architecture isn't coming, it's already here. Let's start with a building that literally defies gravity. DJI Sky City. 2 glass towers appear to float in mid-air above Shenzhen. DJI Sky City looks exactly like what the world's largest drone manufacturer would build a headquarters designed to fly. Massive cantilevered sections hover with no visible support. But how do you make glass towers look weightless while supporting thousands of tons? How do you integrate drone testing facilities into occupied office space 9 stories up? A hidden central core system distributes the load across an invisible steel skeleton. The glass hides precision engineering that lets the towers extend outward while appearing to defy gravity. Drones fly through testing facilities built directly into the architecture. The building doesn't just house drone technology, it is drone technology. But floating towers were just the beginning of Shenzhen's revolution. Tencent Headquarters, Shenzhen. 2 towers rise 820 feet into Shenzhen's skyline, connected by sky bridges suspended in thin air. Tencent's headquarters houses 50,000 employees across twin structures that lean toward each other, creating visual tension that makes the complex appear to be moving. But connecting 2 skyscrapers with bridges at multiple levels without destroying structural integrity, that's the engineering nightmare. How do you keep them linked when typhoons make each tower sway independently? AI-powered systems that learn in real time. The sky bridges have expansion joints, allowing independent movement while staying connected. Smart climate control cuts energy by 40%. The bridges aren't walkways, they're collaboration ecosystems, with gardens and meeting spaces floating 800 feet above ground. 2 buildings functioning as one intelligent organism. Huawei Oxhorn Campus. Huawei built an entire city disguised as a headquarters. 4.6 million square feet sprawling across Dongguan, with buildings shaped like ox horns curving across the landscape. 120 separate structures connected into one campus. 12 European-themed towns replicated inside a single corporate complex. This isn't a headquarters, it's a small country. But how do you connect 120 buildings without chaos? How do you move 100,000 employees across a campus spanning miles? How do you maintain efficiency when your headquarters is larger than some actual cities? An autonomous train system covers 7 miles of track linking every section. Green building technology slashes energy consumption by 30% across the entire complex. The curved oxhorn design isn't just aesthetic, it's engineered for optimal airflow and natural cooling. Huawei didn't build a headquarters. They built a functioning city that happens to design smartphones, from sprawling campuses to sleek, impossible towers. OPPO Headquarters, Shenzhen. The O Tower rises above Shenzhen as a perfect ring of glass and steel. OPPO's headquarters is literally shaped like the letter that starts their name, a circular structure with a hollow center. It's one of the boldest geometric designs in modern architecture. But circular buildings create nightmares. How do you design interior spaces when there are no straight walls? How do you support a ring structure without a central column? How do you fabricate thousands of curved glass panels when no 2 are identical? A structural system distributes weight evenly across the entire curve, turning the weakness of a circle into its strength. Advanced facade systems track the sun's position throughout the day, adjusting to maximize natural light while minimizing heat. Every curved glass panel was custom engineered using parametric design software. The ring shape that seemed impossible became the most efficient design possible. But when it came to touching the sky, Shenzhen saved the best for last. Ping and Finance Center. 1,965 feet straight up into the clouds. Ping and Finance Center is China's 4th tallest building, a tapered giant piercing Shenzhen's skyline like a steel needle. 15,000 people work inside a structure that sways in winds most buildings never experience. But at nearly 2,000 feet, you're not fighting gravity, you're fighting typhoons. How do you keep a super tall tower stable when wind forces at that height can snap steel? How do you prevent motion sickness for workers on the top floors? How do you even build a foundation strong enough? 1,700 dampers installed throughout the structure absorb wind forces, eliminating sway completely. The tapered design cuts wind resistance by 40% compared to straight towers. The foundation drills 180 feet into bedrock, 60 feet deeper than the building is wide. Smart systems slash energy consumption in half. This isn't just tall. This is engineered dominance over physics itself. And Shenzhen's skyline had one more bamboo shoot waiting to grow. China Resources Tower. 1,280 feet of flowing curves inspired by bamboo shoots breaking through the ground. China Resources Tower doesn't fight the sky, it grows into it. The entire structure follows organic, non-linear patterns that make it look alive. But creating smooth curves on a super tall building? That's structural insanity. How do you engineer a glass facade that follows organic lines with no repeating patterns? How do you support asymmetrical forms at that height? How do you hide the steel skeleton needed to keep it standing? A diagrid system, diagonal steel grids, distributes loads while remaining invisible beneath the bamboo-inspired exterior. Energy efficiency runs 30% better than building code requirements through natural ventilation and adaptive facades. The curves aren't decoration, they're aerodynamic optimization. Form and function merged into a living sculpture that happens to house thousands of workers. But Tencent had another vision, waiting to twist into reality. Tencent Helix. 2 towers spiral toward the sky like intertwining strands of DNA. The Tencent Helix doesn't just stand, it twists. Double helix architecture reaching hundreds of feet up, with each tower wrapping around the other in a continuous curve that defies every rule of traditional construction. But here's the problem. Twisting structures want to collapse. How do you keep 2 spiraling towers stable when the floor plates change shape at every single level? How do you connect spirals without breaking either one? How do you even construct something that has no straight lines? A double helix steel framework where each tower supports the other through the spiral connection itself. The twist isn't cosmetic, it's structural. Green terraces spiral up the entire exterior, following the curve. Every beam, every connection point, every floor plate was custom engineered because nothing repeats. Innovation literally twisted into steel. From biological inspiration to geometry that shouldn't exist. CCTV Headquarters. 2 towers lean toward each other at impossible angles, then connect at the top with a 90-degree cantilever hanging 525 feet above the ground. CCTV Headquarters in Beijing is a loop of steel and glass that appears to be falling in slow motion. 768 feet of architecture that breaks every instinct about how buildings should stand. But connecting 2 leaning towers with a horizontal section weighing tens of thousands of tons? That's not construction, that's a physics experiment. How do you assemble an overhang 50 stories above ground? How do you distribute 550,000 tons across a structure designed to look unstable? Revolutionary diagrid steel structure, a lattice of diagonal beams forming triangles that spread the load across the entire loop. 6 years of construction where engineers calculated stress on every single joint. The building that everyone said couldn't be built became the building that redefined what skyscrapers could become. Gravity didn't win, engineering did. While Beijing got impossible loops, Hangzhou got pure fluid motion. OPPO Headquarters, Hangzhou. Flowing glass curves wrap around the structure like water frozen mid-motion. OPPO's Hangzhou headquarters is the opposite of their Shenzhen ring. This one moves. Organic architecture with curves in every direction, where no surface is flat and no angle repeats. But engineering curves in 3 dimensions simultaneously? That's a fabrication nightmare. How do you create structural stability when the building flows like liquid? How do you manufacture 12,000 unique glass panels when each one is a different shape? Advanced parametric design software calculated every curve mathematically. Each of the 12,000 glass panels was custom fabricated using digital precision. The structure beneath uses diagonal bracing that flexes with the curves while maintaining earthquake resistance. Beauty and strength in perfect balance. The building appears to flow but is engineered to withstand disasters. Innovation takes many forms, including making buildings that heal you. Infinitus Plaza. Infinitus Plaza isn't just a headquarters, it's a health experiment at architectural scale. LEED Platinum certified from day one, designed to make 8,000 employees healthier just by showing up to work. A building where air quality exceeds hospital standards and natural light reaches 80% of workspaces. But achieving the highest green building certification while housing thousands, that's expensive and complex. How do you filter air and water at massive scale? How do you reduce waste by 90%? How do you make sustainability actually work instead of just look good on paper? Advanced filtration systems recycle 90% of water throughout the building. Air quality sensors in every zone maintain hospital-grade standards continuously. Natural light optimization through smart glass that adjusts throughout the day. The architecture itself became health technology. Infinitus didn't just build green, they built a building that actively improves the people inside it. And then, someone decided to build a literal spaceship. Netdragon Headquarters. A full-scale starship sitting in the middle of a Chinese city. Netdragon Headquarters is shaped exactly like the USS Enterprise from Star Trek's saucer section, nacelles, and all. The most audacious corporate building ever constructed, where a gaming company turned science fiction into engineering reality. But making a spaceship design actually function as office space? That's beyond ambitious. How do you engineer a saucer section and nacelles as real structures that won't collapse? How do you take a fantasy seriously enough to make it structurally sound? How do you convince engineers this isn't insane? Complete structural integrity hidden inside science fiction form. The saucer section uses radial steel beams spreading from a central core. The nacelles are real buildings connected by reinforced skywalks. It works. It stands. It houses real employees doing real work. The building proved corporate architecture doesn't have to be boring. It just needs engineers brave enough to try.